Today we will discuss novel vesicular formulations. Novel vesicular formulations, that means the dosage form or novel drug delivery system which is available in the vessel format. So till now we studied about the liposomes and phytosomes. Those are also vesicular formulations, and apart from that there are other novel formulation available like the liposome, transferasome, ethosome, phospholipids, etc. Actually phospholipid is not that, but vesicular formulation like the liposomes, transferasomes and the ethosomes. So we will discuss this in detail. Today we will discuss transferasomes in detail. Okay, now just see the picture which is on your screen. Like the liposome, the structure is here. This is liposome, this is ethosome, then transferasome and transethasomes. Okay, so you can see a difference. That is a hydrophilic drug, hydrophobic drug is there. You can see in transferasome, aqueous solution is there and age activators are there. So that is a major difference. Now in ethanol or ethosome, you can see hydroalcoholic solution at the central core. Okay, and transethosome, hydroalcoholic solution. So first one, liposomes or liposome, we studied in previous session. Liposome, hydrophilic drug inside the core. Then ethosome, hydroalcoholic solution. That means ethanol and water is inside the core, while transferasome, aqueous solution is at the center, but the difference is in age activation. And then last one is a transethosome, that is hydroalcoholic solution. So let us discuss this in detail. What is a transferasomes? Now, vesicular formulation, we will discuss transferasome, ethosomes. Apart from that, there is a neosomes, okay, etc. is present. Then we will discuss between difference between phytosomes and liposomes, advantages, properties, applications. Okay, so all these we will discuss in this lecture. We will discuss only transferasome in today's session. Okay, so what is a transferasome? We will discuss first. It was discovered by Gregor Sevek in 1991. Transfere meaning to carry across, and soma means the body. So it is derived from the Greek word transfere. It means to carry across, and the Greek word that means soma, that is nothing but the body. Now it is an artificial vesicle which resembles the natural cell vesicle. So this vesicle, it is similar to the natural cell vesicle. And transferasome, it is highly adaptable and stress responsive complex aggregate. Now, if you compare this with the liposome or phytosomes, those are novel drug delivery systems, but those are not adaptable or stress responsive as compared to the transferasome, because it is a very stress responsive and adaptable because the age activators or surfactants are present in the preparation of transferasomes. Now this is again a diagram of the transferasome. So you can see hydrophobic solute is there, and important part, that is a age activators are there. So all these constitutes the transferasome. Now let us discuss a conventional liposome. Already we studied this is central core and this is a layer, cell layer, and drug has to pass through this. Okay, now ultra deformable sesquosome vesicle, let us discuss that. So it consists of the phospholipid bilayer which is also there in the lipid or liposomes. Then at the center there is a presence of water. Then you can see blue, it is phospholipid, and we can say age activators or the membrane softeners are added. Now these are the ultra deformable vesicles. Membrane softness, that means it helps to soften or provides elasticity to the this transferasome. Okay, so these membrane softness are major difference between the liposomes and the these ultra deformable transferasomes. So ultra deformable vesicle, which possesses an aqueous core surrounded by the complex lipid bilayer, it is called as a transferasome. These are self-optimized aggregates with the ultra-flexible membrane, and they are able to deliver the drug reproducibly either into or through the skin, depending on the choice of the administration or application with high efficiency. Then it is or transferasomes are more elastic than the standard liposome and thus well suited for the skin penetration. And flexibility of transferasome membrane is achieved by mixing suitable surface active components in the proper ratios. So these edge activators or the agent which provide elasticity are surface active components. We can say surfactants. Those are providing the flexibility to the transferasomes. Now let us discuss the mechanism. Now you can see a skin, yellow color membrane. It is shown, that is a skin, and our drug molecule. This is a drug molecule. This is a conventional drug molecule, which is a large than this central pore. Okay, so this is a very small pore is there on the skin, and drug molecule, say for example liposomes. Okay, it is a conventional vesicle or phytosome. It is a larger in size. Okay, so it is not possible to pass easily through these pores. Okay, but if we compare that with the transferasome, those are the ultra deformable or having a flexibility. So because of these edge activators, it will change the shape. So initially it will deform, and then once inside the layer, it will again reform it. Okay. So this is the transferasome. So have property of deformation and reformation. So it is similar to the, we can say, rubber ball or rubber elastic. So if you press it, it will deform it, but after releasing pressure, it will again gaining its shape. That is a reformation. And these transferasomes are having a deformation and reformation capacities. Okay. And if we compare that with the liposome, those are not highly deformable vesicle. So to pass through that, either you have to minimize the size of the liposome, or you have to select a different route of the administration. But here, as we know, it is very difficult to penetrate through the screen, through the skin, and these transferasomes are elastic, flexible, and they can easily transfer from this, and therefore many skin preparations are available in the transferasome form. Okay. Now, let us discuss the structure and composition. Transferasome is composed of phospholipids like phosphatidylcholine, which self-assembles into lipid bilayer in aqueous environment and closes to form a vesicle. And a lipid bilayer softening, biocompatible surfactant or an amphiphilic drug is added to increase lipid bilayer flexibility, permeability, and known as an edge activator. Lipid bilayer softening component, it is a biocompatible surfactant or an amphiphilic drug is added to increase lipid bilayer flexibility and known as an edge activator. Okay, so these are the softening, lipid bilayer softening component. An edge activator consists of usually single chain surfactant of non-ionic nature that causes destabilization of the lipid bilayer, thereby increasing its fluidity and the elasticity. And flexibility of transferasome membrane can be altered by mixing suitable surface active agent in the proper ratio. Again, the same diagram is there. So different additives which are used in the formulation of transferasome includes phospholipids. Phospholipids are the main use is vesicle forming components. Example like soya phosphatidylcholine, dipalmitoyl phosphatidylcholine, etc. So first, that is a phospholipid. Second one is a surfactant for providing flexibility, like the sodium cholate, sodium deoxycholate, twin 80 span 80. Alcohol, this is wrong. So alcohol like ethanol and the other alcohols can be used as an solvent, and buffering agent, saline phosphate as a hydrating medium. So these are the different additives. So first one is a vesicle formulating agent, then the flexibility providing agent, then solvent and hydrating medium. So all these together constitutes a transferasome. Now, let us discuss the advantages of the transferasome. So, transferasomes possesses an infrastructure consisting of hydrophobic and hydrophilic moieties together, and as a result, can accommodate drug molecules with wide range of the solubility. So, it is similar to the phytosomes or liposomes. For the molecules with wide range of solubility can be converted into this dosage form. Again, those are biocompatible and biodegradable, as these are made from natural phospholipid similar to the liposome. Okay, biocompatible and biodegradable. Okay, so it is easily degraded in the body, therefore it is considered as a biodegradable, and it is compatible with the body, therefore it is considered as a biocompatible. Then again, have high entrapment efficiency in case of lipophilic drug near to 90%. So lipophilic drug, 90% drug can be entrapped into the central core of the transferasomes. Okay, so have high entrapment efficiency. Then these transferasomes have high deformability, gives a better penetration of intact vesicle. So high deformability, we studied in that diagram. So having capacity to undergo deformation, after that reformation. Okay, so it provides a better penetration into the intact vesicle. They act as a depot, releasing their content slowly and gradually. In that diagram, we discuss that at the central core, a drug is present, and through that membrane, drug has to be released. Okay. So lipid bilayer membrane is there. So because of that, it releases the drug slowly and gradually because a lipid bilayer membrane is present. Okay. So they acts as a depot, and they can be used for both systemic as well as topical route. Mainly transferasomes are available in topical route form, but it is also can be given in the systemic form. And it is scale up procedure is simple and easy, and hence avoid unnecessary use of pharmaceutically unaccepted additives. So all these are advantages of the these transferasomes. Now, before going, the skin is non-porous barrier that only permits the passage of a smaller particle, and thus the passage of transferasome across the skin is due to vesicle membrane flexibility, hydrophilicity, and the ability to perforate the skin barrier. Now, see this diagram. In this diagram, here, this is a picture of a transferasome. Okay, this is a transferasome. Then it is applied on the skin. Here it is a melanoma. Okay, and this structure this structure is taken, magnified to understand the concept. Okay, so this is how you are applying the transparosome on the skin. Okay, so in this diagram, it is shown this is transparosome and it is applied. So the picture of that is taken, that is a melanoma, and these are the cell. Okay, melanoma cell. I hope you are understanding this concept. So this picture is shown here. These are the melanoma cells. So these red color are melanoma cells. Here it is shown that, and the TS is section is taken. Then these are our transparosome. So it will start to penetrate inside the skin. Then through these, it will deform it. That is a deformation, and then again reformation. Okay. So through this melanoma cells, the deformation is taking place, and after that the drug release will taking place at this level. Okay, again here the reformation and the section is taken here, so the drug release will taken place after reformation. So this is the mechanism by which this transparosome may act. Okay, so it is simple. The first one, that is a deformation, then reformation, and then drug release. Okay, so highly penetrating compounds, we can say. Okay, so that is the mechanism. Now let us discuss the difference between liposome and transparosome. Liposomes are made up of phospholipids, and to improve the stability of such vesicle, cholesterol is included in bilayer as a membrane stiffening agent, which lead more rigid, less flexible, and less permeable lipid bilayers. So cholesterol is used. Okay, we studied that if cholesterol is not added, then proteins may have effect on the liposome. Okay, that membrane protein. Therefore, cholesterol is added, and again, due to addition of cholesterol, it becomes a more rigid. That means it becomes a more rigid, less flexible, and less permeable to the lipid bilayers. That is about the liposome. And the liposome that applied locally have cross the skin barrier in a low transport rate and distributed between the cells in the building blocks. Liposome too large to enter the blood vessel locally, they are utilized in peripheral tissues below the application sites. And this is the last part for today's discussion, that is the application of transparosome. Now these transparosomes are having a wide range of the application, like the delivery of the insulin, delivery of the corticosteroids, proteins and peptides, interferons, anti-cancer drug, anesthetics, NSAIDs, and herbal drugs. Okay, so these transparosomes are very useful in a delivery of the various categories drug, we can say synthetic drug as well as the herbal drug. And we'll discuss a few examples among the herbal drug. So curcumin, obtained from the curcuma longa, it is made into the transferosome form, and it shows a better permission for anti-inflammatory activity. Then capsaicin, it is present in the capsicum annum, and it is increases the skin penetration, capsaicin. Then vincristine, it is an anti-cancer drug, and it increases entrapment efficiency and skin penetration. Then colchicine, colchicine autonomial reduction in the GI side effects. Okay, so these are the applications of transferosomes. Okay, now uh, so today we will end our session here with this quote.